The first thing you're going to need to know how to do with a power series, you're going to want to be able to find that radius of convergence. So that's uppercase R. And you're going to want to be able to find the interval of convergence as well. So we have, in part A, the sum n equals 0 to infinity, n factorial times x to the n. And that's representative of the series 1 plus 2x squared plus 3 factorial times x cubed plus 4 factorial times x to the fourth plus dot, dot, dot. So in this case, the Cn is n factorial. So when I say Cn is a constant, it's a constant with respect to x, not to n. Does that make sense? Okay, so Cn is a constant with respect to x. And then you have x to the n. So it is a power series. So if we want to find the interval of convergence, we often or almost always use the ratio test, sometimes the root test, to find the interval of convergence. So it's going to start out looking like the examples we did in the last section, some of them anyway. We're going to do this. We're going to find the absolute value of an plus 1 over an. And we're intending to use the ratio test to tell us which x values this converges for. For which x values this converges. A good thing it's not an English class. Okay. So your an is, remember, whatever the whole thing that comes after the sigma notation. So what would an plus 1 equal? Just in an, just replace n with n plus 1. What do you get?
N plus 1 factorial x to the n plus 1.
Yep. And then you have to divide by an, but here you don't need to think about it in terms of flipping and multiplying. You just divide by an, which is n factorial times x to the n, like that. And it is absolute value. Here the absolute values are important, by the way. You can't just drop them. And the reason for that is we don't know if x is positive or negative. So you can't just drop the absolute values like we have in the past. And the absolute values are going to give us our interval of convergence, so we don't want to drop them. But we do want to simplify like we've done in the past. What is x to the n plus 1 divided by x to the n? Just x to the 1. Okay, the rule, it's a law of exponents. X to the n plus 1 divided by x to the n. You keep the base and subtract the bottom exponent from the top exponent to get the new exponent. So you have n plus 1 minus n as your new exponent, which is just 1. So you have x to the 1 power left over. Okay, so you have this, n plus 1 factorial divided by n factorial. Oh, you know what? Let's do that simplification in this step right away. So how would I want to rewrite n plus 1 factorial to get rid of the factorials?
Just n plus 1
N plus 1 times n factorial, right? And we still have that factor of x on top. We did that simplification in this step. And then n factorial on the bottom. So I would like to see that. And then you can show me this cancellation. So that we get the absolute value of n plus 1 as a quantity times x. But the absolute value splits up over multiplication. So you can split this up into the absolute value of n plus 1, which is just n plus 1, times the absolute value of x. So n plus 1 quantity times absolute value of x is how that absolute value of an plus 1 divided by an simplifies. In order to get convergence, remember we're trying to use the ratio test? In order to get convergence, we need the limit of this guy to be what? We need the limit of this guy to be less than 1. You're right. But for any particular x value, what's the limit of this guy? Remember, it's n goes to infinity, not x. No, we got absolute values, so I think it's infinity, right? So notice, Using the arrow notation, this guy diverges to infinity. So we use the same arrow notation when it diverges to infinity. It doesn't mean it converges to infinity. No, it diverges to infinity. Oh, well, that's bigger than 1, right? But I need to put in, there's a small caveat here. So that's bigger than 1. And so you might think we're going to conclude that this series always diverges for any x value. But there's one x value it doesn't diverge for. 0. So this is true for, we need to put that in there, for all x except 0. For all x except x equals 0. In other words, this big long series only converges when x equals 0. So by ratio test, you got to put in what test you're using at some point. By ratio test, the given series diverges except for x equals 0. So I could have made that all one statement, all this one statement, but that's okay. So by ratio test, the given series diverges except x equals 0. So what does that mean? Well, that means your interval of convergence, which is the values that that the series rather converges for, is, well, it collapses is a good word to use, to 0. So I isn't an interval, it's a collapsed interval. And it just collapses around the number 0, which means the radius of convergence. So if that's an interval with one number, what's the radius? How far out does it go? 0. So that means that r equals 0.